Okay, so this is the tutorial class, tutorial 6, based on the lectures starting from 26 to 30 lecture. So, we will discuss few problems here. The first, let us see, discuss whether the series sigma 1 over n plus root n is 1 to infinity converges or diverges. So, so here we will use the comparison test. If all the terms of the sequence are greater than the certain term and or less than certain terms, and if the right hand side series is convergent, left hand is convergent. If there is a greater than sign, if the left hand side is diverges, right hand side series will diverge. So, using that result we will use. So, we know here, since n is always be greater than square root of n for n greater than equal to 1. Therefore, n plus n will also be greater than equal to n plus square root of n. Hence, this will show that 1 by 2 n will always be less than equal to 1 by n plus square root of n. So, this is the terms of all terms are positive, and this is, but the left hand side series, but the series sigma of 1 by n 1 to infinity diverges, because this is the result. A series sigma 1 by n to the power p, n is 1 to infinity, converges if p lies less than 1, diverges when p is greater than or equal to 1, diverges. So, using this result, this series diverges. Therefore, once this series diverges means the left hand side series diverges. Therefore, right hand side series sigma of 1 by n plus root of n 1 to infinity will also diverge, and that we are using comparison test. So, by comparison test one can say this series diverges. Okay? And this is basically the test is like this. Suppose a n is less than equal to b n, is greater than equal to a n dash, and all positive, then if the series sigma n dash diverges, then sigma of b n will diverge, n will diverge. If the series sigma b n 1 to infinity converges, then sigma of n will converge. So, this test is known as the comparison test, but this should be true for every n, not for few. Okay? If it is true for all n, because this is true for all n, therefore, this is diverging implies this series will diverge corresponding. Okay. Test the convergence of the series sigma u n, n is 1 to infinity, where u n is square root n to the power 6 plus 1 minus square root n to the power 6 minus 1. Solution. So, here again we will use the comparison test, but in the limiting position, because comparison test is when u n is less than v n, then one can identify the convergence of a n if convergence b n. Apart from this, we are unable to get this thing. Then we get the ratio a n u n by b n, and then take the limit, and limit comes out to v l which is greater than 1, less than 1, then only we decide the convergence, etc. So, here we will use the limiting behavior of the ratios. So, let us take v n as 1 by n cube. Now, this also I will tell you why I have chosen the 1 by n cube. The reason is, what is our u n? The u n is n to the power 6 plus 1 minus n to the power 6 minus 1. If we rationalize this number, then divide by n to the power 6 plus 1 plus n to the power 6 plus 1, and then multiply by the same number n to the power 6 plus 1 plus square root plus square root n to the power 6 plus 1. So, when you divide and multiply by this, then what happens is, this comes out to be n cube, here this is a square minus b square. So, n to the power 6 plus 1 minus n to the power 6. So, we are getting this basically n to the power 6 2 times, divide by this part n to the power 3. If we take common, then it is under root 1 plus 1 by n to the power 6 plus under root 1 plus 1 by n to the power 6. Just n to the power 6 outside. So, we are getting. So, now when we are getting this divided by the n cube is left out. So, if we do not have the n cube, we do not want the n cube to be there. So, if I divide by n cube, then its our term is over. Okay. So, that is why we are taking 1 by n cube as our this one. Okay. So, we get from here is n cube to n cube by this part, n cube into this. So, that is why n cube into this. So, this is 1 by n cube u n plus minus 1. So, a square minus b square minus. So, this is wrongly written. This one is wrongly written, a square minus b square. So, here it is wrongly is a, sorry, this will be n to the power 6 plus 1, n to the power 6 minus 1, n to the power 6 plus 1, and this is minus. Sorry, this is correct it. So, here this is plus, this is minus. So, that is why it is 2 over n cube. So, we wanted to get rid of n cube. So, let us take u n over v n when v n is n cube. So, this is equal to limit as n tends to infinity. What we get is, this is the limit as n tends to infinity 2 into 1 over under root 1 plus 1 by n to the power 6 plus under root 1 plus n to the power 6. So, when n tends to infinity, the limit will come out to be 1, and if the ratio of the limit u n over u n plus 1 is different from 0 or infinity, then both this series sigma u n and sigma v n will have the same nature, will have the same nature. Okay. So, now this series sigma of v n is convergent, but sigma of v n 1 to infinity, that is equal to sigma 1 by n cube 1 to infinity converges, because of the previous p is greater than 1. Oh, this is, I am sorry, please look the previous slide, this is wrong, this is diverging and this is convergent. P is greater than 1 converges, P is less than equal to 1 diverges. Please correct the previous slide. Diverges if P is less than equal to 1 and converges when P is greater than 1. So, here P is greater than 1. So, it converges, therefore, this series is convergent. Okay. So, this is what we get. Correction we met. Okay. And this also we have done it n to the power 6 minus this. So, here when you rationalize it n to the power 6 plus 1 and then plus sign and then plus sign. So, when you take the a plus b into a minus b, a square minus b square. So, n to the power 6 plus 1 minus n to the 6 plus 1. So, that is why 2 is getting. So, we get the result. Okay. I think this action is required. Okay. So, 3. The next example is examine the convergence of the series 5 1 2 3 plus 7 2 3 5 plus 9 3 4 7 divided by 11 4 5 9 and so on. Okay. Examine the convergence of this series. So, what is our nth term? The nth term u n is basically 2n plus 3 divided by n plus 1 2n plus 1, where n is 1 2 3 and so on. So, let us take, if we take n here outside and here n, so it comes out to the n by n cube. So, it means 1 by n square if I remove, then the limit will come out to be the constant term. So, choose b n as 1 by n square, where n is 1 2 3, and then divide by u n over b n and take the limit as n tends to infinity. So, this is limit as n tends to infinity. This will come out to be the n square. So, u n will be equal to what? 2n plus 3 and n plus 1 2n plus 1, and then v n is 1 by n square. So, it will go n square. Now, when you take n outside, so the limit will come out to basically a 1 2 and then 2 1, which is different from 0 or infinity. Therefore, but this series sigma b n 1 to infinity is sigma 1 by n square 1 to infinity converges. Hence, the series sigma u n 1 to infinity will also converge, and that is the results for this converge. Okay. Prove that the sum of the series of the series 1 over 1 into 2 plus 1 over 3 into 4 plus 1 over 5 into 6 is log 2. So, this is basically nothing, it is simply a definition. We know log of 1 plus x, the expansion of log 1 plus x is x minus x square by 2 plus x cube by 3 minus x 4 and so on, where the x lies between minus 1 to 1 including 1 right hand side. Now, putting x equal to 1 here, we get 1 minus half plus 1/3 minus 1/4 and so on, and then rearranging the term. So, this will be 1 minus half, then plus 1/3 minus 1/4 and so on, and after rearranging you are getting basically 1 into 2, 1 over 3 into 4 and like this. So, this is nothing the same as this series, therefore, the sum will be log 2. So, here we do not have any problem, we get test. Okay. The next is examine the convergence of this series factorial 2 square y factorial 2 minus factorial 3 square divided by factorial 4 plus factorial 4 square divided by factorial 6 minus factorial 5 square divided by factorial 8 and so on. Examine the convergence of this. So, let us see what is our un. The nth term will be minus 1 to the power n plus 1 factorial n plus 1 whole square divided by factorial 2 n. This is our n, where n is 1 to 3. Now, take the mode of un plus 1 over un. Now, this un over un plus 1 is nothing but what? This will be n plus 2, if I simplify, n plus 2 whole square divided by 2n plus 1, 2n plus 2, 2n plus 2, and then take the limit as n tends to infinity, limit as n tends to infinity. This limit, when you take n square outside from here and n from here, you are getting 1 plus 2 y n whole square over 2 plus 1 y n, 2 plus 2 y n, is it not? And then limit as n tends to infinity. So, basically this is 1 by 4, 1 by 4, less than 1. Now, we have seen earlier also that this un's terms are positive, negative, hardly matters, but limit of un plus 1 by un is coming to be less than 1. So, this implies that limit of un must be 0, tending to 0. So, un must go to 0 as n tends to infinity. This was the ratio test in the first lecture tutorials we have taken in tutorial number 4, that if the terms un is any sequence, and if the un plus 1 over un is less than 1, the limit of un will be 0. If it is greater than 1, limit comes out to be infinity. So, now the series are terms are alternately positive, negative, and the limit of un is tending to 0, hence it is convergent. So, here the terms of the series are alternately positive and negative. They are of decreasing nature, and tending to 0. So, by Leibniz test, the limit of the series sigma of un 1 to infinity converges. So, that is what it is converges. Is it okay? Now, test the convergence of the series sigma 1 by n 2 plus 1 by n 1 to infinity. It simply look like this. So, here if we choose V n as 1 by n square, where u n's are 1 over n square into n to the power 1 by n. So, what is the limit of u n over V n as n tends to infinity? This is the limit of 1 by n to the power 1 by n as n tends to, which is 1, different from 0 or infinity. So, by ratio test, by comparison test, the series sigma of u n converges if sigma of B n converges. Here sigma of B n means sigma of 1 by n to the power p, b is greater than 1, convergent, is convergent. Therefore, this series sigma of n square 1 by n 1 to infinity is convergent. Okay. So, this is what test for the convergence of the series sigma n is 1 to infinity 1 plus 1 by n to the power 3 by 2 raised to the power minus n to the power 5 by 2, n to the power 5 by 2. Okay. So, here the u n term is 1 plus n to the power 3 by 2 raised to the power minus n 5 by 2, n is greater than equal to. Now, here if we look, the u n term is given where the power is there. So, instead of ratio test, we will apply the nth root test. So, let us see what is the u n to the power 1 by n when n tends to infinity. This is the same as limit n tends to infinity 1 plus 1 by n 3 by 2 power minus, and when you take this one. So, what is it is minus 1 by n. So, it is only n to the power 3 by 2, and that will be the same as limit as n tends to infinity 1 over 1 plus 1 by n 3 by 2 raised to the power n 3 by 2. Now, this is nothing but the e. So, it is 1 by e, because this limit is there, limit as x tends to infinity 1 plus 1 by x raised to the power x is e. This result is valid, is known. So, 1 by e, and e is greater than 1. So, it is less than 1. Therefore, the series sigma of u n 1 to infinity converges. Why? Nth root test. Okay? Because nth root test says if limit of u n to the power 1 by n is L, what is nth root test? If the series sigma u n is there, for this, if limit of u n to the power 1 by n is L, L is less than 1 convergent, greater than 1 diverges, and equal to 1 test fails. Okay. So, here it will be. So, this is a convergent series, limit of this is less than 1, therefore, this. Discuss the convergence, of the series of the series sigma n is 1 to infinity 3, 6, 9, 3n divided by 8, 11, 14, 3n plus 5 x to the power n, x is positive for various values of x. Okay. Solution. So, let us take un. What is un? 369 into 3n divided by 8, 11 and 3n plus 5. So, if I take un plus 1 over un and then simplify it, we are getting into x to the power n. So, when we are getting, you are getting 3n plus 3 divided by 3n plus 8 into x. So, limit as n tends to infinity is nothing but x. Now, the convergence of this will depend on the nature of x. Now, if x is less than 1, then it is convergent, but greater than 1 diverges and equal to 1 test fails. So, in order to justify for x equal to 1, we again put the equation 1 and then take the limit un plus 1 over un and then this consider 1 minus this into n, take the limit as n tends to infinity. So, we apply the Rabish test for x equal to 1 and this limit is nothing but the limit n tends to infinity 5n over 3n plus 8 and that value come out to be greater than 1. Therefore, this Rabish test says for series converges for x equal to 1. So, this is convergent for x equal to 1, hence the result. Okay. Thank you.